Okay, dear friends, again we are solving the same paper May June 2017, paper 6 variant 1, and our question is right now on the thermal physics, and the class will be investigating the cooling of water. So the class is investigating question number 3. The class is investigating the cooling of water. Figure shows the apparatus. Cooling of water. So you can see the arrangement: stand with the bosses and clamp. Thermometer is clamped in the mid of the water tub or beaker. And one of the accuracy which they may ask in the next questions as we will process forward. So thermometer bulb should not touch the sides of the container or beaker or the bottom of the beaker. It should be within the liquid. And here the bulb is within the liquid. Thermometer in figure 3.2 shows the room temperature theta r at the beginning of the experiment. So record theta r. What is that? 20, 21, 22, 23. So yes, Mariam, correct. It is 23, but in degree Celsius. Then next is a student pours 200 centimeter cube of hot water into the beaker. She measures the temperature theta of the hot water in the beaker. She immediately starts a stop clock, and after 180 seconds she measures the temperature of the theta of the hot water, and then again after an interval of further 160 seconds, mean after 360 seconds she measures the temperature theta of the hot water again, and the numerical values are given. Initial temperature was 85 and the final temperature was 66. Now see, calculate the temperature fall theta 1 during the first 180 seconds. So delta theta 1, it is equal to 85 minus 74 equal to 11. So here 11, but don't forget to write degree Celsius. Then during the delta theta 2, during the next 180 seconds, it means that is 74 minus 66, it will be equal to 8. So we can say 8 degrees Celsius. Suggest why delta theta 1 is different from delta theta 2. I'm waiting for your response. Mean time interval is same. Why the answer is different? Mariam, we can say like this, but more suitable term you can say that for delta theta 1, initial temperature is much higher than room temperature. This you can say difference of temperature more, so rate of cooling more. O or R, only one mark, so you can write this, or you can say for delta theta 2, just reverse the argument that initial temperature is less, initial temperature is closer to the room temperature. Like this you can say initial temperature is closer to room temperature, or difference of temperature is less between the initial temperature and room temperature. So anyone you can say, if the difference of temperature will be more, so rate of cooling will be more, or rate of heat losses to the surroundings will be more. Another student plans to investigate the factors affecting the difference between the values of delta theta 1 and delta theta 2. Suggest two changes that he could make to the procedure to obtain larger value for this difference. Mean right now difference of only 3 degrees Celsius. What should he do to increase this difference? So 2 marks, he should measure it for longer time differences. Like right now he measured it for 180 seconds. He should measure it for longer time differences. So then the difference of the temperature will be more. It is he or she, I don't know. It is yeah. So he should use longer time difference. say. Second, she should use a wider beaker. Okay, so then more heat will be lost to the surroundings. Actually, quickly, more heat will be lost to the surroundings. So she should use wider or larger surface area, wider beaker. So then more quickly heat will be lost to the surroundings. So this difference will become more. Many things you can say. Even you can say increase the temperature of hot water. The initial temperature is more, so more heat loss will be there, so difference will be more. Or decrease the volume of the water. Even you can say keep on stirring, so it will also make the difference. Many answers you can do for this stuff. Okay, so actually the question was, again let me say, student wants to investigate the factor affecting the difference between the values of delta theta 1 and delta theta 2. Right now in the experiment which we have conducted in this, or we have solved in this, the difference in delta theta 1 and delta theta 2 is only 3 degrees Celsius. He wants to increase this difference. So many factors, 2 I have written and I told you 3 more. Now the volume of water used in this experiment is measured using a measuring cylinder. Figure 3.3 shows the measuring cylinder. A, B, C and D are 4 possible position lines of sight that could be used to read the volume of the water. So give 2 reasons why B should be used to obtain the most accurate B. Lower level of meniscus, we are always using. Second, line of sight is at what? 90 degrees. So you can say a reformula question, not something very strict or difficult. Next is now pendulum. The class is investigating the motion of a pendulum. Figure 4.1 shows the apparatus, clamp is there, bob is there, and the string is there. So set square and meter rule is there. On figure 4.1, draw clearly the length L of the pendulum, and maybe in the previous experiments I told you length L is equal to L1 plus R. What do we mean by L1 plus R? L1 is the length of the string only, and this one is the radius of the ball. So on figure 4.1 show clearly the length L of the pendulum. So length L of the pendulum, now my dear friends, you can say that is this one as the length of the pendulum. Okay, so left side is your answer. Now use figure 4.2. Sorry, yes. Okay, so now use figure 4.2 to explain how you would measure the length L accurately. You may draw diagram on this. No need to draw the diagram. We can say that keep the ruler close to the pendulum and measure from the bottom of the clamp. So keep the ruler close to the pendulum and measure from the bottom of the clamp. So 2 marks, 2 points are there. Even you can write, that use the ruler close to the pendulum and use the set square to keep the ruler vertical, or use the set square to keep it as the horizontal reference. Mean you have to measure it like here is the set square. Are you with me? From the center, and then draw the ruler here like this. So it will give us the value of L. So this you can also write in your own words. This is the basically other point of the, but we have to go till here. So set square you can use to find the center of the bob, and then as a horizontal reference, and you can measure then with the help of this set square and ruler. Set square diagram maybe I have drawn wrongly. It should be the other way, but it's okay, no problem. So you can draw the set square like this. Okay, I will change it. Like this. Okay, my dear friends, next is then a student determine the period t of the pendulum. The period is the time taken for one complete oscillation. The student measures the time t for 20 oscillations. So n is there and t is there, of course. So t is 20.22. Calculate the period t of the pendulum. So no problem, this formula we are very much familiar with that. Capital T is equal to small t over n, and that small t is 20.22 divided by what is n? 20 divided by 20. So 20.22 divided by 20, answer is 1.011. So 1.011, but here we will write 1.01 seconds. Now there is a query. Yeah, okay, so fine, my dear friend. Explain how measuring explain how measuring the time for 20 oscillations rather than one oscillation helps the student to obtain more reliable value for the period. So it gives an average answer, and the error spreads over 20 oscillations. If you remember, I gave you the example of a businessman doing a business alone, having a big loss and worried, but then he was told by some experienced people that don't start a company alone, make some partners, and then if there will be loss, so it will be shared equally. So same is the case if there is an uncertainty or error. So if it is only one oscillation, so all uncertainty will be over there, over 1. So it will be very high. But if it is 20 oscillations, so that uncertainty will be divided in 20, is divided in 20 or by 20. So it will become less. Next is, the student wants to determine the value of acceleration of free fall. From his results, he needs to take the value of t square to do this. Calculate t square and give your answer to suitable number of significant figures and include the unit. So t square, see 1.011, square of this is 1.022. So 1.02, and very important unit will be square. Don't write here s only because it is squared. So unit will also be t square. So unit will also be second square. So this was another question. Now, my dear friends, planning question, of course. A student is investigating whether the resistance of a wire depends on the material from which the wire is made. So resistance is dependent variable or quantity, and material is independent variable, and we change independent variable and seeing the effect of this on the resistance. Resistance can be found by the formula R is equal to V over I. Student has the following apparatus: ammeter, voltmeter for current and voltage, micrometer, screw gauge, power supply, variable resistor, switch, connecting leads, and wires of different materials. Plan an experiment to investigate whether the resistance of a wire depends on the material from which it is made. So you should draw a diagram of the circuit you would use to determine the resistance of each wire, and then explain briefly how you would carry out the experiment, key variables to control, and draw suitable table. So let's start with the circuit diagram. And what is there in the question? There is a power supply 0 to 3 volt. So the circuit diagram is given below. Start with the power supply sign, this one, circles, then show a switch. Then we know emitter is always in series points, like this is C, this is D, and voltmeter will be connected across the metal resistance wires, and variable resistor to control the current in the circuit here, that is also always in series, and then connected this way. And what is the purpose of this C and D gap? Here, my dear friend, you can add, this is resistance or resistance wires, okay, not resistance wire, see wires of different materials here. Okay, just write wire. This will be the circuit diagram. So as you will, okay, better to label this circuit diagram. Okay, this is variable resistor. At least it will be 2 marks diagram. So variable resistor, this is the power supply, even you can say power source, but they told power supply, so you will say only power supply. This one is a switch. Here this is an emitter in series. Of course, this is a voltmeter, and these are the wire of given material. Not wires, I should write wire of given material, like this. Now circuit is well explained. Now they will ask you definitely how to get the explain briefly how you would carry out the investigation, including the measurements you would take. Now here, my dear friends, first of all, you can say arrange the circuit as shown. Arrange the circuit, even it is not needed, if you are not writing, no problem. Arrange the circuit as shown above, then close the switch, measure current flowing through the wire connected between C and D, and measure potential difference PD. See, current was through the wire, but potential difference across the wire. Across the wire. Now what to do? You have current, you have voltage. Now R will be equal to V over I, but it is not stopped yet here. As I told you, always you have to say that repeat the same method. Repeat the same method by connecting. What was independent variable? Resistance wires, material of the wire. Repeat the same method by connecting wires of different materials. Different materials between C and D. Now this is briefly method to follow to collect the data. Then state the key variables to control. So there are 2-3 things you can control. but I will be writing right now length and diameter, because these are also the factors which can affect the resistance. Even the temperature, okay, two are enough. Length and diameter of wires of different materials must be same. Wires of different materials must be kept constant, or they should be same. Then what is the next point? Draw a suitable table with column headings to show how you would display your readings, and you are not required to enter any value. See, even in table, my dear friends, first of all, it comes the independent variable. You will say type of material, no unit. Then you measure the current, you can write in amperes. Then you measure the voltage, that is in volts. Then you measure the resistance, that is in ohms. So this is the table with column headings. Even if you have short lacking time, so you can write only the first and the last. Mean in the table, dependent and independent variable should be definitely there. Independent variable is on extreme left and dependent variable is on extreme right. Lazim, it is it is necessary you should write these two things in the table. And here, of course, resistance is not directly calculated, so ammeter value means current column should be there, and voltmeter value means voltage column should also be there. In this case, they did not say how to reach a conclusion, but if they have said, we cannot say here that plot a graph of type of material against resistance. Why? Then on y-axis it will be resistant, and resistance on x-axis it will be material, but we don't have the numerical data for material. If the examiner will say how to reach a conclusion that how the resistance is affected by the type of material, then you can draw a bar chart of resistance against material. So material will be on x-axis and resistance will be on y-axis. Material A, material B, material C, and then accordingly you can draw the bar chart. And also you can say keep the current same or slow or less in this question, so that the heating effect of current can be reduced. In electricity questions we can write this point. So these are some important points regarding this planning question. If you have any question, please feel free, and you people can ask me right now. Okay, dear friends, stay blessed.